morning. My name is Sarah Rowley and I'm a Masters by Research student at the University of Salford, working in collaboration with Adria Lopez-Bosales, Ricardo Rocha and Christoph Meyer, who is my supervisor. I'm studying the interplay between local and landscape scale variables in shaping aerial insectivorous bat responses across a fragmented Amazonian landscape. Land use change is the main driver of the global biodiversity crisis. It's estimated that between 1980 and 2012, more than 150 million hectares of tropical forest was converted for agricultural use. However, a large percentage of this land, in particular the land cleared for cattle grazing or pastures, are typically abandoned after a few years, and this gives the forest an opportunity to regenerate. This trend of abandoned cattle pastures and the second growth forest is now a significant feature of the Brazilian Amazon, with 22% of deforested land being occupied by regenerating secondary forests. And whilst pristine tropical forest is of irreplaceable value, this secondary forest does have the capacity to help preserve biodiversity and to buffer the impacts of fragmentation on wildlife in these forest remnants. The issue of deforestation is not easily fixed, and the rate of deforestation in the Amazon is once more on a rise after a significant period of reduction from the peak in 2004. So it's more important than ever to understand how species respond to changes in local habitat quality and fragmentation of the wider landscape. And bats are an excellent indicator of the health or the level of disturbance within neotropical forests. They're abundant, they're diverse, and they're relatively easy to sample. And in the Brazilian Amazon, there are around 150 species belonging to 9 families. Between 2011 and 2013, Adria and Ricardo conducted extensive research on bats in the biological dynamics of the Forest Fragments Project, which is located north of Manaus in Brazil. They collected both MISNet and acoustic data. And one paper which was published based on this fieldwork was focused on disentangling the relative importance of local and landscape scale effects. Ricardo used the misnetting data to analyse species responses, and by virtue of the sampling method, it focused on phyllostomid bats. My project addresses some of the same questions using acoustic data. My focus is on aerial insectivorous bats. There is a large body of research on the responses of phyllostomid bats to habitat loss and fragmentation. However, aerial insectivorous bats in this regard have been much less studied. By jointly investigating all 3 biodiversity facets, taxonomic, functional, and phylogenetic diversity, my study aims to provide a holistic perspective of how local and landscape scale variables shape aerial insectivorous responses to fragmentation. I will further seek to draw conclusions about the scale dependency of the relationship between those diversity facets and the local and landscape metrics. And today, I will be presenting my preliminary findings of this research. All data was collected at the BDFFP, which is about 1,000 kilometre squared area in central Amazonia, and it's the world's largest and longest running study of habitat fragmentation. It was founded in 1979 by the conservation biologist Dr. Thomas Lovejoy. This area includes a series of forest fragments ranging from 1 to 100 hectares in area. It has control sites in the nearby continuous primary forest and study areas in the intervening matrix, which were initially used as cattle pastures but soon abandoned and now feature secondary regrowth forests of varying age and species composition. The BDFFP was designed to evaluate the effects of fragmentation on rainforest biota, but more recently, there has been a broader focus on landscape dynamics, forest regeneration, plus regional and global change phenomena. You can see from this figure how the various stages of forest fragments blend together, and this background photo gives you an idea of what the matrix or the secondary forest now looks like in the BDFFP. So we're dealing with a landscape with relatively low structural contrast between the fragments and the matrix. And bats were sampled across 33 sites during the fieldwork in 2011 to 2013. The interior, edge, and matrix of 8 forest fragments were sampled, and fragment sizes were 3 1 hectare, 3 10 hectare, and 2 100 hectare. 9 interior control sites were sampled in continuous primary forest. I analysed acoustic data that was collected using SM2 bat recorders. I'm working with a subset of the original data, which includes 281,664 calls, which have all previously been identified by ADRIA and assigned to 21 groups of either species level or mixed species groups. You can see here that we have 5 families of aerial insectivorous bats represented within this data set. I'm just going to briefly explain my statistical analysis. I'm using the raw acoustic data. I calculated the diversity metrics through Hill numbers, selecting an inverse Simpson metric for taxonomic, functional, and phylogenetic diversity. It's worth noting I used 7 functional traits as listed here and extracted species phylogeny from the Scheidt and Robuski bat supertree. For my predictive variables, I submitted vegetation data, which was collected from each of the sample sites to principal component analysis, and retained the scores on the first axis as my local vegetation variable. For the landscape metrics, I used satellite images of the BDFFP. I quantified compositional and configurational aspects of the landscape structure. I originally calculated 5 metrics, however, I removed Euclidean nearest neighbour and mean shape index due to severe collinarity. I selected percentage continuous forest cover, edge density, and patch density, and calculated these 3 metrics at 10 focal scales, which range from 500 metres up to 5 kilometres. I then created a set of 11 candidate models based on ecologically plausible combinations of local vegetation structure and the landscape predictor metrics. Each model included a random term accounting for the nested sampling design. We had sites located within a research camp location in the BDFFP. In order to investigate local and landscape relationships with the 3 diversity bat response metrics, the most parsimonious models were selected using Akiyika information criteria and a 95% confidence set created. Model averaging based on Akiyika differences from the best model of less than 2, calculated parameter estimates, and hierarchical partitioning determined the variation independently explained by each predictor variable. This figure shows a summary of the model averaging results. The symbol size is proportional to the variation explained by the respective predictor variable based on the hierarchical partitioning, and the colour denotes the direction of the relationship. Black is positive, white is negative. There are subtle scale-sensitive associations for all 3 biodiversity facets with local and landscape scale metrics. Most of the local and landscape variables seem to be having a negative effect on diversity, apart from functional diversity and local vegetation, which is indicating a positive relationship, and the proportion of variation explained is increasing with the spatial scale, which for a variable that seeks to explain local or small-scale habitat, this result seems a little counterintuitive. You can see that there is a small, again, but consistent effect on edge density on the 3 biodiversity facets. All 3 are reducing as the number of edges increases at smaller spatial scales. And again, it's a subtle effect, but the percentage of continuous forest cover appears to have a positive relationship with all 3 biodiversity facets at the smaller spatial scales. So even though we're dealing with a landscape with low structural contrast, we can see that the 3 diversity facets are affected by local and landscape scale habitat attributes in a scale-dependent manner. Just to give you some context to these results, they are preliminary. I still have to finalise my conclusions, and there is relatively poor model fit and a high level of model selection uncertainty, which makes it tricky to draw solid conclusions as to whether local or landscape scale attributes represent the best predictors of aerial insectivorous bat diversity. Moving forward and away from the community perspective, My next task is to assess ensemble and species-specific responses by analysing bat activity, and I will be looking for relationships from a scale dependency perspective again. And that just brings me on to my last slide to say thank you and acknowledge everyone who's been involved in this wider project, and a special thank you to Adria, Ricardo and Christoph for their ongoing support. And I'm happy to take any questions.